Hey, so I've been messing a lot with cops lately, and specifically learning how to make Python image processors as cop nodes. I've recently released a couple of videos about this, but I actually just made those unlisted because I realized they were super scattered, and I've finessed the process a little bit more. So hopefully I'll be a bit more to the point here. So to do this, well, first of all, why would you want to do this? Basically, the cop-vop nodes where you can write vex to manipulate your image are somewhat limited. They're sort of like a shader. You generally can read and write only a single pixel at a time. I mean, you can sample other pixel values, but you can't write out other pixels than the one that's being processed. And also, if you want to do like a really large scale image manipulation, or for example, read all the pixels at once and do some analysis on it, that's kind of difficult. So using Python, it's pretty easy. How you create your own Python cop node is you go file a new asset here, and then you go Python, and then you choose either generator or filter. These are both very similar in terms of the coding. I don't know if you can change the resolution of a filter, probably not. By default, a generator doesn't have any inputs, but you can easily change that. So I'm just going to start by making a filter, and this will create an HDA. So I'm just going to call this tutorial cop filter. I'm just going to show kind of out the box. This is actually going to be broken. So I'm just going to create a file node. This will bring in the butterfly here. Oh, sorry, I'm in object level. Oops. So let's go in here, create a file in cops. There's my butterfly composite view, excuse me. And now we can create our tutorial cop filter. And we can plug in our input here. It might cook for a second or whatever. It takes a while. So bear with me. Hopefully my Houdini doesn't crash. I'm going to give this 5 more seconds. Okay. So there's an error. What's the error? Cannot find shared object file, CPP inline. So what is actually this thing that I created? Well, if I right click on it and go to type properties here, I go to code and there's a bunch of generated Python. I prefer to do this in an external editor, so I right click, press edit Python source code. This opens in VS Code for me. And let's look at what's broken here. So this inline CPP thing, I could probably install this, but I don't really want to do that. So I'm just going to delete that. And let's kind of look at what is actually happening here. So output planes to cook. So these are what, is obviously going to be modified. So it's only modifying the color plane. You return C. If you wanted to modify alpha, you'd add that in here too. And the required input planes. Kind of similar. This 0 says what input it's coming from, and then you say what the color plane is that you're reading. And then there's the cook function, which does happen every time the node is cooked. So it works with sequences and kind of as you'd expect a cop node to. What does this do? This is assert plain C. I don't know. This is just built-in stuff. Kind of the gist of it, though, is it's reading the color as an array here using this all pixels as string method. So let me just find the doc link. All right, yeah. So there's the docs here on define a compositing node, cop using Python. And if you see, the function they're using is all pixels as string. So I was trying to use this, and I noticed that the numbers were very weird. They weren't like 0 to 1 like I expected. So if you look at the docs here, there's a difference between all pixels and all pixels as string. This is returning a binary string containing the image data in requested format. So if we look at the docs, all pixels as string, it does say there's a way to get floats out of it, but I don't want to deal with that right now. If you want to optimize your node, you could look into this, how to get regular color values out of this, but for now I'm just going to use all pixels here, and then you don't want to use set pixels of cooking plane from string. You just want to use set pixels of cooking plane. So that's these two work together in that regard. Yeah, so what this is doing is it's reading the color values out and it's doing some manipulation here, and then it's setting the pixels of the cooking plane. So basically, if we delete this, we can do whatever manipulation we want in here. And that's kind of the real quick and dirty of cop filters with Python. Now this is like an RGBA. It's called an interleaved array. So you have to be prepared to deal with that. You can use this resolution here. to figure out kind of how to reshape the data into something that's more like UVs. But I'm not going to actually build this whole thing from scratch. I'm actually going to show my kind of template that I've created. So kind of the gist of what we're going to do here is we can basically call external Python. So there's a couple ways you can do that. You can either literally call an external Python using like sub-processes and call your external Python processor, or you can just use the Houdini Python. Now it took me a little while to figure out how to do this, but basically to install Python dependencies to Houdini, it's actually really easy. You just do python-m pip install dependency name, and if you need to install pip to your Houdini, you can just Google how to do that. I'm sure there's lots of resources out there. I forget exactly what you need to do, but I'm sure you can figure that just as easy as I did. And then at that point, you can just import whatever depths you need. And for example, from here, I could obviously write something in a strip tab. I could make a Houdini module here, a Python module, and just do like def foo whatever, right? And then obviously from my from this code, I have access to this cop node here, so I could just say cop node. I forget how to access the module. I have that in my template, so let me just bring out the template, and I'll just tell you. It might take a second to load here, but let me just load up this script. Oops, it's actually a little bit nested. Let me see this. Where do we do this? Yeah, HDA module. So that's what we need to do. So you just say cop node HDA module dot foo, and you can pass this your colors, your resolution, anything you want. You can read parameters on your cop node, whatever, right? This is just normal Houdini Python, basically. Pass your data around. So that's kind of the gist of it. The only other tricky thing here is really into thumbnails. And this was especially problematic with generators because let me just actually get into the generator a little bit here. Let me show my modified generator. Because with a generator, you change your resolution. And how that works is you define this resolution function. And normally this resolution passed to cook automatically by Houdini will be the same as the output resolution. But that's not necessarily true if it's with a thumbnail because it's actually cooking it with a lower resolution. So you just have to be careful if you're relying on that output resolution to like change the image size. It can just be a little problematic. Actually, I haven't really completely figured out how to work with thumbnails. So I'm actually just kind of skipping the thumbnail stuff. I detect if it's a thumbnail, by seeing if the resolution does not match the output resolution. And so actually my thumbnails for these nodes are just black, which is fine. Yeah, so you might encounter this error. The attempted operation failed, invalid sequence string size. So you might have to do something like that. Just skip it if it's a thumbnail. Anyway, let me just first get into the customization of my Python generator template here. So yeah, I have a force recook button. Let me just show how that works. And by the way, if you wanted to use my nodes, you can just go to wiki.dissonant.info here, go to Houdini tools, and here's my package. And then this one, if you install this package, just like a normal Houdini package, it has a JSON file, and then you point it back at the, the package location, and then you're going to get this cop Python generator template. You're also going to get AI Upscale, Dall-E generator, some dithering stuff, etc. So, but for this tutorial, you'll especially want this generator template because I've added some other stuff to it. Basically, it has an output size parameter here. It also has caching, so I can show how that works. Basically, in the cop level, I have a wrapper HDA, which is the one you're interacting with, and then inside of it, there's another HDA, which actually does the cooking. And so this HDA has some parameters. There's a force cook, right, which is calling a force recook function on the scripts tab here, force recook, and that's just you know, fetching that internal node and just calling cook force true. Yeah, and then what else here? So let's take a look at the internal HDA, the internal node here. So yeah, I'm calculating output resolution sort of based on that parameter, which in this case, because the cop node is the inner node, so if I want to read the parameter, I have to go get the parent. And so the resolution function is just fetching that output resolution. I'm only cooking C here. And then let's just skip this write image to cache function because it's kind of a utility function. All it really does is just take the pixel data and write that to a specified file. And then the cook function, right, we already talked about this. How do I check if it's a thumbnail? If it is a thumbnail, I'm just going to set it to black here. This is just, I mean, honestly, if you need some help with Python, you can just do ChatGPT. I've been using ChatGPT a lot just to generate me some NumPy code. I'm not very good at Python, so. But otherwise, we're going to actually go to the HDA module of our parent, call the run function with our desired output resolution. And that is actually found right here. There's a run function, which you can see it just says put your logic in here, and it's defaulting just returning a bunch of zeros. And these utility functions aren't used in this template, but I'll show they're used in the AI Upscale one. But anyway, yeah, so we call write an image to cache, we save it to file, and then one thing I'm just doing here is I'm taking that interleaved data and I'm just converting it to RGBA, like array of pixel values that looks like this. So it's a little different from the single level array that you get, because I'm just getting each pixel into its own little array, and that's this data type I'm calling RGBA arrays. And so I, you know, am building that, and then down here I'm converting that back into the color, the interleaved array type that it expects. Okay, so that's kind of the gist of that, I suppose. What else? I guess I can just show my the Dall-E one, and you can see how it's not so different. So yeah, the code is pretty much inside here, is I believe almost exactly like I showed, except it just has some prompt. It has a prompt parameter, OpenAI API key parameter, output size, and this is, you know, a square value. This is the only sizes allowed by Dall-E. But then if we look at, oops, let me see here. Right, so if we look at our run function, it's just calling this Dall-E generate function, which, you know, you can find the code for this on the, you know, I found this on some coding tutorial website, just saying how to use the OpenAI Dall-E API, you know, OpenAI Dall-E API. It's a tongue twister. So whatever, this basically builds an image file, and then I have a function here which converts that image to the RGBA pixels format. So not particularly interesting. Like I said, you can certainly just use ChatGPT to help you out. It's very good at Python image processing. And yeah, so that's pretty much how this works here. I'm trying to think if there's anything tricky. Not really too much, to be honest. I mean, going back and forth between image formats can be a bit tricky, but you know, just have persistence, and you'll be all right. So let me also just show, well, I suppose I can first show just this thing working. So, well, I don't want to show with my OpenAI, but you can trust me that this works. You add a prompt and then you'll see the image here. Let me just show the AI upscaling one. So first of all, let's take this and make it a way lower resolution so we can do some proper upscaling. Do an AI upscale cop here, plug that in. And that is, yeah, that's a bit upscaled. It's still super pixelated because obviously it's a tiny image for starters. But here we are, we're starting to get a little better. It's a little blurry. You know, it's not perfect, but given what we're working with for starters, I'm not really complaining, I suppose. You know, this will have mixed results. I think this is such a cartoony image. Maybe it's not doing such a good job, but anyway. So this one is a generator which I've added an input to. In here, I just right click, type properties, and I've added an input to it. And so the code in this internal one looks a little bit different. I have to do the output resolution dependent on the input resolution because I'm upscaling. So that's basically, I'm just reading the XRes and the YRes of the input. Input cop here is the inputs, first input. What else here? So that's basically where those, sorry, what have I done? Yeah, those utility functions on the type properties of the, where was it? Here we are. Yeah, the function here is just a bit different. I'm just calling this upscale function. I'm using a different library. I'm actually using the super image thing, which basically just does the upscaling for me. And so yeah, these are just some utility functions here, which just format the image data, but you know, for tensors and preds, and I don't know. I'm just doing, sometimes I just do what I have to do to get these image data types converted between one another. So this is just an example of that. So I'm not really showing the specifics of the Python code. I'm not really like teaching how to do image manipulation in Python. I'm just showing how you can do this with Houdini. And I think I covered it. So I hope that's interesting. I'm not sure if I'm forgetting anything. Hopefully I was a little more to the point. And yeah, please check out my nodes. I'll probably be continuing to make some more of these. So cheers. Yeah.